Unit 1.8, Valence electrons and ionic compounds. Neutral atoms of chlorine are bombarded by high-energy photons, causing the ejection of electrons from the various filled subshells. Electrons originally from which subshell would have the highest velocity after being ejected? So, before we go into this problem, let's look at the chlorine. So chlorine is right over here. In writing the electron configuration of chlorine, it's going to be 1s2, 2 electrons in the first period in the s orbital, and 2s2, 2 electrons in 2p6, 6 electrons in the p subshell of period 2, and 3s2, 2 electrons in the s orbital in the period 3, and it's gonna be 3p5 because chlorine is the fifth one, 1, 2, 3, 4, 5 of orbital p of period 3. So the electron configuration of chlorine is gonna look like this. And so the question asks, electron originally from which subshell would have the highest velocity after being ejected? So highest velocity means that it's gonna go the fastest after being ejected, and that means it's gonna have lower ionization energy. And the electrons that have the lowest ionization energy is always gonna be the last one, the valence electron. And it's because the valence electron, the most outer electrons are gonna be in the most outer shell, so it's gonna take up less energy to remove that electron than any other core electrons like these. So the answer is gonna be 3p5. An electron from this subshell would have the highest velocity after being ejected.